If the DC bias voltage, which is VD, across a reverse biased PN step junction is equal to negative 1.2 volts, then what's the capacitance of the junction in femtofarads? Before we continue on with this problem, let's highlight what we know. So we have a VD, and that is our PN equal to negative 1.2. And it's reverse bias. So we have VD, we have this mention of reverse bias, and it's equal to negative 1.2 volts. So VD is our, again, reverse bias. So we're going to say that this is equal to like our VR, and this is equal to 1.2 volts. And this is going to be like an absolute value, so 1.2 volts here. Then we're asked what is the capacitance of this junction in femtofarads. So capacitance of the junction is equal to, we don't know. And this is in femtofarads, so this is times 10 to the negative 15, which is equal to 1 femto. We're going to assume that our CJ0 is equal to 37.4 times 10 to the negative 15 for our femto. And then we're also going to assume that the built-in voltage, so this is our VO, and its built-in voltage for the junction is equal to 812 millivolts. So it's equal to, we'll just write 0.812 because a milli is 10 to the negative 3. And so if we are to use this equation that we have here, I just control find, looked up capacitance. This is PN junction for the capacitance of the junction. And we plug this into a calculator. So again, looking at the formula, we have our CJ0 on top, so 37.4. Notice how I didn't do the times 10 to the negative 15. That's because we want our answer in femtofarads. And this is over our constant 1 plus our VR. And our VR is the 1.2 volts divided by our 812, and I just put 812 times 10 to the negative 3. That's going to be the voltage output. Now, what is our M? Well, if we scroll down a little bit, M is equal to half the abrupt step functions. We're not dealing with linear junctions. That would be cross bias point, where it's more linear, I believe. But for here, what it's asking us for, we're going to use 1/2 as our M. So that's what we're plugging in right here. With that done, we are going to get the value of approximately 23.8. Now, if your values are different, you just plug in the different values here. And that's how we go about solving this problem.